Alright, so where we left off, we said if the force applied is 50 newtons and the angle is 5 degrees, is that force applied greater than or equal to the force of friction plus Fgy? Okay, so to answer this, we have to write out our Newton's two equations, but even before that, we need to break Fg up into Fgx in the direction parallel to the hill, and Fgy the direction perpendicular to the hill. Okay, so we know that Fg is equal to mg, and in this case, m is 30 kilograms, g is 10, so Fg is equal to 300. Okay. Fgy will be 300 cosine 5 degrees, if that is our incline. Fgx will be 300, because this is opposite, sine 5 degrees. Okay, and we can calculate those two numbers. And when we do, we find that Fgx is equal to 26.14 and Fgy is equal to 298.9. Okay, now we can write out our Newton's second law equations. We know that in the y direction, we have no acceleration because this thing is not jumping in or out of the hill. Okay, so in the y direction we have Fn up minus Fgy down is equal to 0 because there's no acceleration in the y direction. Okay, so we have Fn minus 298.9 equals 0, and we quickly see that Fn is equal to 298.9. Okay, in the x direction, we don't actually have to calculate the acceleration. We just need to test out. So we know Fa is 50. Okay, we need to know what is the sum of the force of friction and Fgy. Okay, so we know that Ff plus Fgy is going to be mu times Fn plus and that should be Fgx because that's up and down the hill, plus 26.14, which we found over here. Okay, so I'm writing greater than or equal to with a question mark above because we still need to plug the numbers in. Okay, so we have 50 might be greater than or equal to, we know that mu is 0.1, Fn is 298.9 plus 26.14. Okay. And when we add those two things together, we end up with 56.02, so the answer is no. 50 is not greater than or equal to the force they need to push. They need an extra 6.02 newtons. Okay. On page 28, it asks, describe as you would to a non-physicist how steep the ramp is by comparing its steepness to something which you are familiar. Okay, so let's think about 5 degrees. And the way that I'm going to figure out what could also be 5 degrees is I'm going to figure out how tall something would need to be if the length was, or actually if the hypotenuse is 5 meters, what does this height have to be? Okay, to figure this out, I can use SOHCAHTOA, and I know that the height would have to be 5 times sine 5 degrees. And the answer is, if the hypotenuse was 5 meters long, so that's, a good chunk of my classroom, then the change in elevation would be 0.43 meters. Okay, so the answer is, the only thing I can compare this to is a ramp at a movie theater. Okay, there are lots of other things, but this is what I would compare it to. Next, it wants you to describe the force that somebody is expected to exert by comparing it to something which you're familiar. Okay, so the question is, how big actually is 50 newtons? Okay, 50 newtons, the way we can think about that is how much would something have to weigh in order for us to have to use 50 newtons. So 50 newtons is some mass times 10. We know that that mass would have to be 5 kilograms. Since 1 liter of water is 5 kilograms, and 1 gallon is about 4 liters. 5 kilograms is like 1.25 gallons of milk. Okay, so I hope this has been helpful in terms of solving hill problems, and you will get more practice in solving these types of problems tomorrow.